So first, the different types of equations. So there are 3 types, and every time I teach these types of equations, I am always reminded of when I was in high school, and we had a quiz about the different types of equations, and that was one of the quizzes that I failed. I got an F on the quiz on the types of equations because I couldn't remember what they were, and I was writing things like, I know this one starts with I. That's not enough to get any points because I couldn't remember the name. So that has stuck with me, as that was something I really struggled with, is remembering all of these. So an identity equation is when you get something that is like both sides are equal. So both sides are the same or identical. So if you go through the solving process, you might end up with something like 0 equal to 0, which is a true statement, but it doesn't really tell you anything. Basically, the x's will disappear, and you'll be left with 2 numbers that equal each other. That's what's called an identity equation. And when you end up with that, your solution is all real numbers. Because if there's no x in the equation, it doesn't matter what x is. Whatever you have is always true. The next type of equation is called a conditional equation, and that's where you actually get a number for x. So you have, when you solve, you get x equals some number. And so that's the most common type of equation, is we have conditional equations. And so your solution is whatever that number is. And then we have the contradiction, where you get something that's false, basically, when you're solving. An example would be that if you're solving and you get x equals, or 0 equals 1. Well, that's not true. We know 0 and 1 are not the same thing. So if you get something that's not true, and with contradictions, you tend to also have the x disappear, that means there's no solution because it's false. These things are not actually equal. So when you're solving and you have an answer for x, it's conditional. If your x's disappear, it's either an identity equation or a contradiction based off of whether your things are equal or not equal. So that is the difference between the 2 different types of equations, or the 3 different types of equations, but the 2 different, the identity and the contradiction. So it's important when you're going through solving, because you need to know whether, okay, my answer is a number or my answer is all real numbers or no solution. And generally, you can't really identify these until you start going through the solving process. So you won't be able to tell when you look at the equation. You have to start solving in order to figure out which of the type of equation is. So moving from that, we have linear equations in one variable. So a linear equation in one variable can be written in the form ax plus b equals 0. They're not always written in this form. Basically, what makes it linear is that there is no exponent on the variable. And if there's no exponent on the variable, it's assumed 1. So you could say the exponent is 1. And then there's only one variable, hence linear equation in one variable. So you won't have a y. You'll just have an x, or maybe you'll have another letter like t or something else, but there's only one variable present. So that's what makes it a linear equation. It doesn't have to be in that form. That's just what they call standard form. The basic steps when you're solving, and this is like the big picture that you want to know when you're solving. So when you're doing algebra, you need to first identify the type of equation and then know what the steps are. So the first thing is you need to be able to look at an equation and say, oh, this is a linear equation in one variable, this is y. There's no exponent on the variable, and it has one variable. So you need to first say, okay, this is the type of equation I have. How do I solve this type of equation? And that's then when you go here, you say, okay, this is how I solve this type of equation. So it doesn't matter what it looks like, you need to be able to identify the type and then what the steps that you follow. And then you follow those steps. So don't worry about how this, I haven't seen a problem that looks like this before. Worry about if you know, if you can recognize the type and then the steps, and then you follow the steps, and then you should be fine no matter what it initially looks for. So the first step is to simplify, and you need to simplify both sides of the equation, following the order of operations, combining like terms. So you basically, you do any distributing that you have on both sides, you add like terms, you simplify each side as they are until you're going to end up with something like a variable and a number, basically. Sometimes there's only a variable on one side, sometimes there's only a number on one side, but you need to simplify it down so that you have at most 2 terms on each side. So I should say at most, because you could have 1 term on each side. Terms on both sides. And that's when you've finished the simplifying, is when you have at most 2 on both sides. From there, we start reversing the order of operations to solve. So when you're simplifying, you follow the order of operations. Multiplication and division happens first. When you're solving, you reverse that. So we do the addition and subtraction first, and then the division and multiplication. So then you're going to add or subtract on both sides. And that is using the addition property of equality. And usually you have to only do it once. Sometimes you have to do it twice. But you should never have to do it more than twice. And then once you've done that, then you usually have 1 step left, and that is to divide or multiply on both sides. Most of the time we divide, which is why I put that first. And that is using the multiplication property of equality. And that is just, you only need to do that once. So you have 3 main things: simplifying, adding, subtracting, dividing, multiplying. And those are the 3 major steps for solving. So I have several examples, and I've picked them, and they increase in difficulty as we go. So I'm starting from the simplest one and then moving from here. So we have solve 7 minus x equals 19. And check your solution. So you can always see if you've done it correctly by checking your work. So when you're solving, you should never be like, I don't know if my answer is right, because you can check to see if your answer is right. So first is to simplify both sides. And in this case, we don't need to simplify because we don't have any like terms, and we have 2 terms on the left, 1 on the right, so we don't need to simplify anything. So then we move on to the adding and the subtracting on both sides. So the goal is that you have to get something. Your goal is to have x equals a number. And you want to have a positive x, or a 1x. So on the left side here, there is a 7. We don't want that 7 there. We don't want that on that side. So it's a positive 7, and what you do is you always do the opposite because you want to make it 0, so you want to undo it. So we have a positive 7 on the left, so we're going to subtract 7 from both sides. So this is where we always want to work vertically. So I write it underneath, and you want to subtract it from what it matches with. So we can subtract that from the 19. So I'm subtracting 7 both sides, and then 7 minus 7 is 0, so I don't need to write that. And I need to make sure I follow down with my sign. So I have that minus in front of the x. So I have a minus x, and then 19 minus 7 is 12. So once you have one thing equals one thing, that means you don't have to do any adding and subtracting anymore. And that's when you move on to your division or multiplication. I always do division. So here we want to have 1x, and we have a negative 1x. So if there's no number, you can pretend that it's a 1. So we have a negative 1. We want it to be positive. And so you divide by what number is in front of your x, because it's negative 1 times x. So that's implied multiplication there. So we're going to divide. You do the opposite to undo it. So we're going to be dividing by -1. And I write it as a fraction because sometimes when you do these, you end up with fractions as your answer. So I show my work as a fraction. So negative divided by negative is positive, and that's where we get just x, and then I get a -12. So that is our answer. Our answer is x equals -12, but we do want to check your work to make sure you've done it correctly. And so you check it by plugging that into the original problem. So I'm going to replace x with -12, and I have to make sure I put parentheses around that so that I don't mess up my signs. So we had 7 minus x, so now I have 7 minus -12. So when you are subtracting a negative, that is the same as adding. So that is the same as 7 plus 12. And 7 plus 12 does get me 19. So when you're checking and you end up with the left side equals the right side, that's a check. You got it right. And so that is your solution. So then you know your answer is -12. You did your work correctly. So I said I'm getting a little more complicated. So now I have 2 terms equals 2 terms. So we have 5x plus 3 equals 6 minus 2x. And from here on out, I'm not going to bother checking because I know my answers are going to be correct. You know, I'm confident in my solving abilities. And that will save us some time because I do have a lot of examples. But I recommend for you guys to always check your answer, always double check. So unless you've been doing this for years like I have, it's just always good to double check because then you know for sure you're right. And then if you're not, if you're like, okay, my answer didn't check out, that's when you can send me an email and send a picture of your work and be like, here's my work, where's my error, and then I can help you out. So our goal is still to have x equals a number. So we're still heading towards that goal. And so I always like to have my x's on the left, my variables on the left. It doesn't matter, you can put them on the right, but I like to have them on the left. And so what I do is I always move my x's first. I always do that so that I make sure I have them on the correct side, and then I move from there. So we have a minus 2x on the right. I want all of my x's to be on the left. So I need to add and subtract. We don't need to do the simplify step because we have 2 terms equals 2 terms. So I'm going to do the opposite. I have minus 2, so I'm going to add that. So I'm going to add 2x to both sides. I'm going to line it up with the x on the left, because those are like terms. So 5 plus 2 is 7. So I have 7x, and then I need to drop down my plus 3, and then that is equal to 6. Now we have something in the form as the first example here. We have 2 terms equals a number. So now I have to do a second addition subtraction step because I don't have something with x equals a number. So I have a plus 3, we do the opposite. So I'm going to subtract 3 because I want to get that 3 away from where the x is. So that gives me 7x equals 6 minus 3 is 3. So now I have my x equals a number, but I have a 7 in front of there, and I don't want to have that 7. So that's 7 times x. So I'm going to divide to get rid of the 7. And you always divide by what's in front of the x. So I'm going to divide by the 7, which gives me an x. Now here, this is why I write it as a fraction, because our answer here is a fraction. It's going to be 3 over 7. You don't want to put that on your calculator and get a decimal. For one thing, that's extra work, because then you got to pull out your calculator, type it in, when all I had to do here was just write 3 over 7. So if you're getting a decimal, that's more work than you need, because all you need to do is basically literally write what I had above it. And secondly, usually you end up having to round, and then once you round with a decimal, when you plug it back in, it's not going to work because it's not the exact answer. So always keep your answers as fractions unless your original problem started with decimals or it tells you to give your answer as a decimal. If you don't have decimals in the original you're given, don't give your answer as decimals. So leave it as a fraction. It's actually less work. And then it will, when you check your answers, you'll actually get things that match. Because once you start rounding, then your things won't match, and then you'll think you have the wrong answer when you don't. Here's example 3. So now here is one where I have 3 terms on the right, and so this is where I have to simplify, because I should have no more than 2 terms on both sides in order to do the addition and subtraction step. I have 3, so I need to simplify the right side. And I'm going to do that by adding the like terms of 8y and 6y. So my left side is going to stay the same, and so I'm going to copy that down, and then I'm going to add 8y and 6y. So 8 plus 6 is 14. It gives me 14y, and then minus 5. So now I'm back to the previous example where we had 2 things equals 2 things. And so this, I want to have my y's on the left. Whatever is with the variable, that has to go on the left side. So I need to move the 14y. So I'm going to ask you guys this. Am I going to add 14y to both sides, or am I going to subtract 14y from both sides? So you can type your answer in the chat box. Elizabeth, you're saying we're subtracting. That's correct. So we want to subtract because that's a positive number. So I'm going to subtract the 14y from both sides. 5 minus 14. Now this is where I'm not very good with math, mental math for some reason with negatives. So if you're trying to do stuff in your head, you know, here's how I think about it. I do 14 minus 5, which is 9. So this is going to get me a negative 9 because 14 is negative and it's larger than 5. It's good practice to try to do these things in your head, but if you try to do it in your head and you make an error, that's where your final answer is. You might have messed up. So if you know you're not very good with like doing 5 minus 14, and for some reason when I'm subtracting something like that where the result is 9, I tend to mess that up. Use your calculator. There's no reason you shouldn't, you know, use your calculator, make sure that your arithmetic is correct. Sorry. Okay, so we have minus 9y plus 1 equals negative 5. So what would be my next step from here? What am I going to do next? Go ahead and type that in the chat box. Okay, so Elizabeth, you're saying multiply or divide. I would hold off for that, and that's the reason why I would wait on that step is because I still have 2 things on the left here. I've got the minus 9y and the 1. So because I still have 2 things on the left, we don't want to do the multiplication or division yet. We want to wait until there's 1 thing equals 1 thing. So I would do another addition or subtraction here. And I would look at that 1, because I don't want that on the same side as the y. So I would want to subtract the 1 from both sides. And I'm doing that because I have a plus 1, so the opposite of a positive is a negative. So then I have a negative 9y, and then negative 5 minus 1 is negative 6. Now this is the point where I would multiply or divide here, because now I have 1 term equals another term. So on the left, I've got this negative 9 times y. I need to get rid of that negative 9 because I just want to have a y. I don't want to have any numbers there. So it's multiplied. We're going to divide. We're going to divide both sides by negative 9. You need to make sure you take that negative with. A lot of people forget that to also include the negative. So we've got everything other than the y, we need to divide both sides by. And now I'm going to move a little arrow here. So I have negative 6 over negative 9. So negative divided by negative is a positive. So I have 6 over 9. But 6 over 9 can be reduced. So I can divide both of those values by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So this gives me a final answer of 2/3. So you always want to make sure that if you get a fraction, you reduce your fraction as much as possible to get your final answer. Okay, so again, I'm making things more complicated. So here we have 9x minus 10 equals 5x plus 2 times 2x minus 5. So left side we have two terms. There's nothing to simplify on the left. On the right, we technically have two terms because the 2 parentheses 2x minus 5 is two terms. But we can simplify further. We can distribute. So distributing, if you have anything you can distribute, you always want to distribute. So I'm going to distribute by multiplying the 2 through the parentheses there. So my left side is staying the same. 9x minus 10 equals 5x plus 2 times 2x. That's going to give me 4x. 2 times, you include the negative, so that's 2 times negative 5, and that's a negative 10. So we have 9x minus 10 equals 5x plus 4x minus 10. So now we have three terms on the right, so we need to simplify, and we do that by adding the 5x and the 4x. So 9x minus 10, 5x plus 4x is 9. We get 9x minus 10. Now I'm going to stop right here. What do you guys notice about the left side and the right side of the equations here? It's the same. Perfect. Yes, Elizabeth. The left side is equal to the right side. So I'm going to go back to where we had the types of equations. When both sides are identical, basically the left side is identical to the right side, that tells us this is an identity equation, and we are going to get a solution that is all real numbers. So I'm going to go back to our example. This is telling us we have an identity, and our solution is all real numbers. Now, what if you didn't notice that? What if you're just going through the solving steps and you didn't notice that the left side and the right side were equal? Well, if I go through the solving steps, I want to move the 9x on the right, so I'm going to subtract 9x. 9 minus 9 is 0, so my x disappears, and I'm just left with negative 10 equals negative 10. Well, if you go to that point, you see, oh, negative 10 equals negative 10. My x has disappeared, and that's something that's true. So that step will also indicate that you have an identity because you have the left side equal to the right side. They are identical there. Now, what if you were just like, okay, now I moved the 10, and you're still going on. You're not even, you're just in your mode. If I add 10 to both sides, that gives me 0 equals 0. And again, that will tell me that I have an identity and my solution is all real numbers. So some people go all the way to the end and get 0 equals 0. Some people, they notice, oh, wait a minute, my equation is identical. The left side is identical to the right side. The answer is all real numbers. So, if you want to, I say, work smarter, not harder, or whatever that saying is. Use some critical thinking, and you notice, the sooner you notice that it's identical, the less work you have to do. But you'll get to the same answer no matter what method you use there. So as soon as you notice that the left side is identical to the right side, then you have an identity, and that tells you all real numbers. And if you want another way of writing this solution, you could use interval notation. Saying the solution is all real numbers is the same as interval notation and saying negative infinity to infinity. Otherwise, there is actually a symbol for all real numbers, which is an R with like 2 lines on the left. That symbol indicates the real numbers, and so sometimes if you can write that as well. Those are all equivalent solutions, and they all indicate that it's all real numbers. Next slide. Okay, so here is where I am getting into the fractions, and this is where the part where it said rational expressions that lead to linear solutions or linear equations. So a lot of people don't like fractions. There is a trick when you have fractions, or when you have equations that have fractions. There's a trick that you can do to get rid of the fractions in your equation so that it's back to a normal equation to solve. And this is called clearing fractions. And so to do this, you need to figure out what your common denominator would be, or what the greatest common, or not the greatest common factor, but basically what would be the common denominator. And so we've got a 5 in our denominator and a 3. So those don't have any numbers in common. But if I do 5 times 3 and get 15, I can make these both have a denominator of 15. So we want to have a common denominator of 15. And so what we do, we find out what that common denominator would be, and then you multiply both sides by that denominator. So I'm going to rewrite this. So that's going to be 15 times 2x over 5 plus 5x. And then 15 times 4 thirds. And then I distribute. So I'm going to do 15 times 2x over 5. So I'm going to show every step here for the fractions. So 15 times 2 is 30. So that is going to give me 30x over 5. 15 times 5, that's 5 times 25, 5 is 65x. Let's see, 25. No, that is, wait. 50, 60, 75. Should be 75. I should double check that with my calculator. Just to make sure I multiply that one correctly. 15 times 5, 75. Okay. And then 15 times 4 is 60, so that gives us 60 over 3. Now I'm going to reduce these fractions. So 30 divided by 5 is 6, so this gives me 6x plus 75x equals, and then 60 divided by 3 is 20. So now we've gotten rid of the fractions, and we have something that's much easier to solve. So we have 6x plus 75x. Those are like terms, so we can add those together on the left. That gives us 81x equals 20. And so now I need to get rid of that 81 on the left. That's 81 times x. So I'm going to divide both sides by 81. And then I'm going to just kind of move to the right here. And that gives me 20 over 81, which does not actually reduce. 9 is the only thing that goes into 81, and 9 does not go into 20. So we get this answer of 20 over 81. So the trick here is that you identify what your denominator is, multiply everything by that denominator, and then the fractions will reduce out and basically disappear, and then you can solve like normal. You don't have to use the smallest number for the denominator. You can use something bigger as long as it is the denominators, the numbers are factors of that number. So 3 and 5 are factors of 15, so that works. The most common error people do is they forget to multiply everything by that denominator. So that's why I put it in parentheses, so that you can see the distributing, and then I show the distributing step. Here's another example. Now this is a special type of rational equation where you have a fraction equals another fraction. When you have something like this, this is called a proportion. These types of things are actually not as complicated as this, but proportions are actually a lot of seen in health fields. So when you have a fraction equals a fraction, there's a special trick where you cross multiply. You multiply the diagonals together. So you want to cross multiply. So your first diagonal, it doesn't matter which one you do first. I usually do the bottom and the top. So that's 5x plus 6 times 1. So I'm going to, even though multiplying by 1 doesn't do anything, I'm going to actually write that out. And then we have 10x plus 3 times 2. I always put the number in front so that it looks like distributing. So that's 1 times 5x plus 6, 2 times 10x plus 3. So now we distribute. So when we multiply everything by 1 on the left, we're just going to get 5x plus 6. So that's nice and easy. On the right here, I need to distribute. So first I have 2 times 10x, so that's 20x, and 2 times 3, which is 6. So now 5x plus 6 equals 20x plus 6. So I'm going to go through the solving process. I like to move my x's first. I want my x to be on the left, so I'm going to remove the 20x, that's positive, so I'm going to subtract 20x from both sides. So 5 minus 20, that's negative 15x, plus 6 equals 6. Now I'm going to subtract the 6 from both sides because I just want the x. So that's minus 6 minus 6. Got negative 15x. 6 minus 6 is 0. You do have to write something there. You can't just leave it blank. It does have, there is a number. It's 0. And now 15x equals 0, or negative 15. I want regular x, so I need to divide both sides by that negative 15 to get rid of it. I'm going to try to squeeze this in here. Move that to the right. So 0 divided by anything is 0. So that gives me the answer of x equals 0. Now, because we have variables in the denominator of our fraction in the very beginning, we have to take a look at what the domain would be. We have to look at, well, wait a minute, what if we're dividing by 0? What if we find a number for x and that number would we end up dividing by 0? So we have to go back to this 5x plus 6. Let me just change my color here. So that 5x plus 6, whatever, we have to make sure that that doesn't make us 0. Because if that equals 0, we have a problem. So we need to make sure that we solve this. So I'm going to subtract 6 from both sides. And I got 5x cannot equal negative 6. Then I'm going to divide both sides by 5. And x can't be negative 6 over 5. So since we got an x value of 0, we're okay. But if we had solved and we got negative 6 over 5, we would have a problem because we just determined that we can't have negative 6 over 5 because that would make the denominator 0. So if that happens, then that means you actually have no solution because you got an answer that doesn't actually work. In this case, our answer works because it's not negative 6 over 5, so we're okay. So you could say your answer is x equals 0 and you feel fine. Now sometimes, I know that some of the problems on the quiz, what they will want you to do is then write a comma just to make sure that you know that 6 cannot equal negative 5. Or x cannot equal negative 6 over 5. And you just have to specify the domain there, that x equals 0 and that x is not equal to negative 6 over 5. So when you're going through the quiz, and you're not going to see that this week, but week 3, when you start seeing the quiz and take the quiz, just keep that in mind, that it will have some of those exclusions because we have fractions and we have a variable in the denominator. So you just have to make sure you keep that in mind, and that when you're looking at your choices, it's really looking at the domain there for that rational expression.